This one causes confusion usually. The dots at the right represent 7 towns that are to be joined by telephone cables. If each town is connected directly to each of the other towns, how many cables will be required? And the hint is you are joining 7 points, 2 at a time. What makes sense, because if I connect this town to this town, there's my connection. I'm connecting those 2 towns with a telephone wire. I could also connect, let's just consider this town A. Actually, let me label them all. C, D. I'll just go clockwise from A. So I could connect town A to E, or town A to B, A to C, A to D, A to F, A to, like that. Why did I put it? That should be a G. All right. I could do AB, AC, AD, AE, AF, and AG. Now, when I go, let me just grab a different color. When I go to connect B to the other towns, I don't need to connect B to A, or I don't need to consider that as, I don't need to count that again because it's already been counted. AB and BA are the same thing. But I would connect B to C, D, E, F, and G. And so you see that we've got this, it's very much like the rap battle situation where I'm awarding 2 medallions. A, B, and BA are the same. And so we need to divide by 2 factorial. And this is a situation where it's a combination. The order in which I connect towns A and B does not matter. As long as I connect them, they've been connected. And so this is a combination of 7 towns taken 2 at a time. 7C2, it's 7 factorial, over 7 minus 2 factorial, 2 factorial. Or 7 times 6 times 5 factorial, over 5 factorial times 2 times 1. 5 factorials cancel. 2 and 6 have a common factor of 2. It becomes a 3, and 7 times 3 is 21 possible ways. If I went through and, I wonder if I should do it. Why not? Let me keep getting different colors and see if we can see this. You see that the blue connections, there were 1, 2, 3, 4, 5, 6 connections. And when I get to B, why do I feel like I missed one? 1, 2, 3, 4. No, that's right. There were 6 blue connections. 6 blue plus 5 red. You'll see a pattern. Plus 6 plus 5, expect 4, right, if it's a pattern. So C, I don't need to connect C to B or A because they've already been connected. But I do need to connect C to D, E, F, and G. So there's the 4. Let me get a different color. Plus, we would expect 3. When I go to connect D, it's already been connected to A, B, and C. So I only need to connect it to E, F, and G. So there's the 3. I might run out of colors. When I connect E, I only have 2 connections that I still need to make, E to F and E to G. And when I get to F, I only need to connect it to G. There's the plus 1. G, I don't need to connect to, G's already been connected to every other possible town. So there's the, in fact, if you have a arithmetic sequence like this, do you see the 6 plus 1 is 7? Do you see the 5 plus 2 is 7? And do you see the 4 plus 3 is 7? Well, look, 7 times 3. 3 pairs of 7. Amazing. So the 21 should have an S. There's 2 of them, there and there. If there were 50 towns, how many cables would be required? Well, that might seem like a much harder problem, but it's really not. I'm not going to diagram that one, though. 50C2 is simply 50 factorial over 50 minus 2 factorial, 2 factorial. So 50 times 49 times 48 factorial divided by 48 factorial times 2 times 1. So the 48 factorials cancel. 2 times 1 is 2, and 50 divided by 2 is 25. So 25 times 49, that's 980, and 225. 980 and 225. Well, 980 and 20 is 1,000. 1,205. I don't feel extremely confident about this. Let's see where I have the I showing up. Oh, I'm off by 20. 1,225. I let a 20 slip through the cracks somewhere. Okay.